Hi, today we are on the topic of complex number. We will use the Euler form to solve this particular question. Now, as you know, Euler form is related to De Moivre's. Now, let me show you, let me run through a few important properties of the Euler equation. Now, first you have ei theta plus e minus I theta. Now this is equals to 2 cos theta. Now if ei theta minus e minus I theta, you will get 2I sine theta. Now how about ei n theta plus e minus I n theta, you get 2 cos n theta, and ei n theta minus e minus I n theta, you get 2I sine n theta. Now you realize that this and this are actually similar, because when n is 1, you will get the first equation. Now for the equation, the fourth equation, all right, the last one, now when n is 1, you get the second equation. Now you can use De Moivre's theorem to prove these four identities or these four formulas. Now for today, I will just show you the formula number 3, but you can do the same thing and you can try out on your own to prove the rest. Now, what is ei n theta? This is equals to cos n theta plus I sine n theta, and ei minus n theta, you get cos minus n theta plus I sine minus n theta. Now you learn in trig, minus n theta, cos minus n theta is actually cos n theta, and this is minus I sine n theta. Now you have equation 1 here, and you have equation 2. Now if you use 1 plus 2, ei n theta plus ei minus n theta, you get 2 cos n theta. Okay, so I have proven formula number 3. Now let's move on to this question. Now today I'll be using Euler formula to prove, all right, to find the real and imaginary parts of W. Now you can also use De Moivre's theorem, or you can just use your normal trig identities. Now, so let me show you how to find the real and imaginary parts by using the Euler formula. So let me just copy down the expression first. W is equals to EI 4 theta minus 1 over 1 plus EI 2 theta. Now, for the numerator, I take out EI 2 theta. EI 2 theta. So what is left will be EI 2 theta itself, because earlier on was 4 theta. So you bring a 2 theta out. So according to the law of indices, this will become 2 theta. Now this one will then becomes EI, E minus I 2 theta. Okay. For the denominator, I will take out EI theta. So I have EI theta into E minus I theta plus EI theta. Okay. Now you look at this. What will you get for this? EI theta minus EI 2 theta minus EI 2 theta. What will I get? Now you look at this formula. All right. So I will get 2I sine 2 theta. All right, for this expression here. And this is EI 2 theta will remains. All right, EI 2 theta. Now, here I will be left with EI theta. And what is this part that is in the bracket? I will get 2 cos theta. All right, this is the first formula. Okay, this part is from the first formula. Now, so this cancel out. What is left behind is EI theta, according to the laws of indices. Now, so you can break this out into polar form, all right? That is cos theta plus I sine theta. Okay? And this 2 also cancel out over here. So I'm left with I sine 2 theta. Maybe instead of writing the whole denominator sine, so I just put times 1 over cos theta. Okay? So this multiply by this, all right? I times I, you get what? Minus 1. So you have minus sine theta sine 2 theta over cos theta. And this multiply by this, you get plus I cos theta sine 2 theta divided by cos theta. Okay, this one I can cancel out. Okay. Now, so what is the real part? Okay, maybe I just use a different color. The real part will be equals to minus sine theta. Now, sine 2 theta, I use a double angle formula, can be written as 2 sine theta cos theta. So here will be 2 sine theta, so it becomes sine squared theta cos theta over cos theta. Okay. Now, so maybe I put real part of W, sorry, there should be a. Now, so this, if I simplify it, will be minus 2 sine squared theta. All right, this cos theta actually cancel out each other. Now, so the imaginary part of W. The imaginary part of W is just this. So is sine 2 theta. In the next video, we will be working out this particular question. We will use these two formulas which we have learned today, and I will approach this sum using two different methods. I will be putting in the URL link in the description below. We hope to see you again. Have a nice day.